Hello once again everyone. Today we are going to look at elements in group 17. Okay, group 17 elements. So they consist of fluorine, chlorine, bromine, iodine, astatine, and tennessine. Group 17 elements are called halogens. Now, where do we find halogen in our daily lives? We see halogen in bleach, that's chlorine. Some of you are familiar with Clorox, right? There's chlorine in bleach. Bromine is used as a substance in fire extinguishers, and iodine is used as a disinfectant. If you are in St. John's or Red Crescent, you would probably have used iodine before. It's the brown liquid used to clean wounds. Now, as we go down group 17, what are their changes in physical properties? As we go down the group, you can see that chlorine is a gas, bromine is a liquid, and iodine is solid. What does that mean? It means that melting point and boiling point increases as we go down the group, and density also increases. Right, so that's the physical property. And we also notice that chlorine gas is greenish yellow in color, whereas liquid bromine is reddish brown in color, and iodine is purplish black. So you can see that the colors from light to dark to even darker. Okay, how about their chemical properties? Now, all of the group 17 elements have 7 valence electrons. Therefore, they have the same chemical properties. Because of the same number of valence electrons, therefore, they have the same chemical properties. So, chemical properties refer to their reactions. So, what kind of reactions do they have? Now, please use your QR code app and take a look at these 3 reactions. Halogens can react with water. Halogens can react with iron. Halogens can also react with sodium hydroxide. Okay, so these are their reactions. Whenever there's a reaction, there would be a chemical equation. Now, how do we write chemical equations for group 17 reactions? Okay, first of all, let's take a look at the general equation. Okay, so group 17 elements have 3 reactions. Now let's write the general equation. Okay, for the first reaction, right? I'll just write the first reaction now. General equation: halogen plus water will produce an acidic solution. Okay. Now write the specific equation based on this general equation. Okay, so we want to study 3 different halogens: chlorine, bromine, and iodine. So let's follow the general equation. So the halogen is chlorine. It reacts with water, okay, to produce an acidic solution. This is double arrow. Okay, so we will get HCl and HOCl. Okay, just follow the general idea. Okay, if you know one, you know all. Alright, so bromine reacts with water to give you HBr. So you replace the Cl with Br. Okay, they are both halogens, right? HOBr. Okay, same thing for iodine. Follow the same pattern, alright? It's the same pattern. Replace the Cl or the Br with I. Okay, and then here again, replace with I. So that is the first reaction, halogen and water. Okay, now we want to look at the second reaction. So general equation would be halogen plus metal gives you metal halide. Okay, so let's write a specific equation now for all three halogens that we are studying. So we start with Cl, chlorine, plus use iron as the metal. Right, so we have metal, iron is the metal, right? So metal halide. Halide comes from the word halogen. Halide comes from the word halogen. So metal halide. Okay, so this is metal halide. So if you want to say the words, it will be chlorine reacts with iron to produce iron 3 chloride. Okay, but this equation is not balanced. So we need to balance the equation. There are 2 Cl's and 3 Cl's here, 1 and 1. So we need to make these 2 and 3 balance first. So how do we do that? Can we put 2 in front here? If I put a 2 in front here, that will be 4 and 3, still not balanced. If I put another 2 here, that's 4 and 6. It's not balanced. So let's try by putting 3. Okay, if I put a 3 here, that's 3 times 2, 6. And then here, let's make this into 6. So I put a 2 in front to balance. So 2 times 3 is 6. Okay, so there are 6 Cl's and 6 Cl's, so it's balanced. But now there are 2 Fe's and only 1 Fe here, so I need to put a 2 in front. Okay, so same goes, same pattern. So once you know one, you will know all already. So use the same pattern, Br2, alright. Replace the Cl with Br, okay. Replace the Cl with I. Okay, so you have your halogen, alright, that's the halogen. You have your metals and you have your metal halides. Okay, that's the second one. Let's move on to the third reaction. The reaction is a bit long. Halogen plus an alkaline solution. Alright, that gives us a metal halide, a metal halide. Okay, so that's the general equation, yeah. Okay, specific equation. So Cl2 alkaline solution. Can you think of an alkaline solution? What is an alkaline solution? NaOH. Okay. So metal, that's the metal from there. Halide, from the word halogen. Metal. Halate. When you see ATE will always have an O in it. Okay, so halate and water. Alright, same pattern. For bromine, NaOH, NaBr, NaOBr, and water. So just follow the same pattern for iodine as well. NaOH, NaI. Okay, remember to replace the halogen, and then replace the halogen and water. Is it balanced or not? How many chlorines are there? 2 chlorines on the left side of the arrow, 2 chlorines at the left side of the arrow, 1 Na only, but there are 2 Nas here. Okay, and then O1, but H, oh no, O1, but this side 2 O's. H also 1 on the left side of the arrow, but on the right side of the arrow 2H. So what must I do? I put a 2 in front. Right, so now I have 2 Nas on the left side of the arrow, 2 Nas on the left side, on the right side of the arrow, 2 Nas on the left side of the arrow, 2 Nas on the right side of the arrow. Okay, same. Now we have 2 O's on the left side of the arrow, and 2 O's on the right side of the arrow. Okay, 2 H on the left side of the arrow, and 2 H on the right side of the arrow. Is it balanced now? 2 Cl's, 1, 2, 2 Brs. Okay, so it's balanced. So all group 17 elements have the same chemical properties. They have the same reactions. But what's different? Their reactivity is different. When going down group 17, the size of chlorine atom is small. Go down to bromine atom, the size of bromine atom is bigger compared to chlorine atom. And the size of iodine atom is much bigger compared to chlorine atom and bromine atom. Now, as I said earlier, every atom wants to achieve stability. So how does chlorine atom achieve stability? What is the electron arrangement for chlorine atom? 2.8.7. So chlorine atom will receive 1 electron to achieve stable octet electron arrangement. Bromine atom same, 2.8, 0.18, 0.7. Okay, so valence electron is 7. Therefore, bromine atom wants to receive 1 electron to achieve stable octet electron arrangement. Iodine atom, okay, don't worry about the number of electrons in the inside shells. We just look at the number of electrons in the outermost shell. How many are there? The outermost shell. One, two, three, 4, 5, 6, 7. So there's 7 electrons in the outermost shell of iodine atom. So valence electron is 7. So iodine atom wants to receive 1 electron to achieve stable octet electron arrangement. The thing is this. Remember, from nucleus to valence electron in chlorine atom, distance is small. So it can attract electron very easily because the force of attraction between the nucleus and electrons is strong. So chlorine is the most reactive. It's opposite of in group 1. Okay? As we go down group 17, reactivity decreases. Why is iodine atom less reactive compared to chlorine atom? Because the distance of the nucleus and the valence electron is much further. So the attraction force between nucleus and valence electron is weaker. So it's harder for iodine atom to attract another electron. Okay? So that's why iodine atom has more difficulty in attracting electrons to fill the valence shell as compared to chlorine atom. So chlorine atom is more reactive, followed by bromine, followed by iodine.